right, we are starting Unit 13 with this video, and we're going to begin by looking at kind of reviewing what we know about mixtures, because we're going to be focusing on solutions, and a solution is a type of mixture. So if you remember from the fall, we said there were two different types of mixtures, heterogeneous mixtures and homogeneous mixtures. So the definition of a heterogeneous mixture is a mixture that does not have a uniform composition in which the individual substances remain distinct, meaning you can kind of tell what the different parts of the mixture are. We used examples like a salad where you could see all the different parts, or a chocolate chip cookie, or things like that. So we're going to be looking specifically at mixtures where things are mixed with water, for example. Okay, so the first type of heterogeneous mixture we're going to look at is a suspension. And a suspension is a mixture that has particles that settle out if left undisturbed, and you could also separate it by filtering. So, like muddy water is an example of a suspension. If you let it set, all those particles are big enough that they can settle down to the bottom, or you could filter them out. When you do a reaction that makes a precipitate, that would be considered a suspension, and if you leave it, all of that precipitate would settle down to the bottom and you could filter it out. A second type of mixture that's considered heterogeneous is called a colloid. And a colloid is something you might not have heard of before. The particles are intermediate in size, so what that means is they don't settle out and they can't be filtered, but it's not exactly a solution, which is what we're going to be focusing on next. So these colloids, when we talk about colloids, we're looking at the stuff that is dissolved in or mixed with the dispersion medium. So when we use that term dispersion medium, for example, in an aqueous solution, that would be considered water. And then we're going to be really looking at the phase of the things that are dispersed in the dispersion medium, meaning are they solids, liquids, or gases? So here are a bunch of examples of colloids, and this might help explain if you've ever wondered, is this stuff solid, liquid, or gas? Well, there's a good chance that it's a mixture of two different things, so it doesn't really fit into one category. For example, Jell-O. Okay, everybody asks, is Jell-O a solid or a liquid? Well, technically, it's a colloid, which is a mixture of, and you can see right here, blood is in the same category as gelatin. It's a mixture of a solid dispersed in a liquid, okay? And then you can see other things that are considered colloids. Mayonnaise, marshmallows, whipped cream, smoke, fog, things like that. Those are all considered colloids, and they're types of mixtures. Now, what's cool about colloids is, yes, they don't settle and you can't filter out the parts, but you can't really see through them necessarily. And they have two very important qualities. The first is called Brownian motion, and it's basically the jerky random movement of particles that result from the collisions with each other, and that's what keeps the particles from settling in a colloid. And then the other cool thing about a colloid is called the Tyndall effect. And what that means is the dispersed particles in a colloid are big enough that they scatter light, okay? Whereas in a suspension, they're too big, they actually block light. And we'll see in a solution, they are too small and they don't scatter light at all. So the best example I can think of here is when you're driving through fog. Okay, when you're driving through fog, the rule is you want to keep your headlights pointed at the ground. You don't want to point them into the fog because fog is a colloid, and those tiny little water particles that are suspended in the air, they're going to scatter the light. So you're not going to be able to see through it with your headlights because of the Tyndall effect. I will show you some examples of all of these things in class. So we'll have an actual visual example of suspensions, colloids, and now solutions, which are considered homogeneous mixtures. And they're the two parts of a solution. These two vocabulary words that you need to know are, the solute and the solvent, okay? We're going to focus mostly on aqueous solutions, which means that the solvent is water and the solute is whatever is dissolved in the water, okay? Now, Solutions don't have to be aqueous, okay? So you can have gases and solid solutions existing, and here's some examples of those. So for example, air is considered a solution. There's mostly nitrogen in air, and the oxygen is mixed in with it, okay? Carbonated water, so sodas, for example, are solutions, but in that particular solution, there is a gas dissolved in the water, okay? Same thing in like ocean water or pond water. There is oxygen dissolved in the water. You can have liquids dissolved in liquids, like vinegar is acetic acid dissolved in water. Okay, you can have solids dissolved in liquids, like salt water. Sodium chloride is a solid dissolved in water. So there are lots of different solutions. We're going to focus on the ones where water is the solvent. Okay, so let's look at a couple more vocabulary terms here that go with solutions. A substance that dissolves in a solvent is considered soluble, okay? And when two liquids are soluble in each other, they are considered to be miscible liquids. Alcohol and water, for example, are miscible liquids. You can dissolve any amount of them together. A substance that does not dissolve in a solvent is insoluble, and two liquids that can be mixed but separate shortly after are immiscible. So water and oil would be immiscible liquids. Okay, so that gets us through some of our vocabulary, and then in the next video we are going to focus on all of the calculations that go along with how much stuff can dissolve and whether or not they can dissolve based on temperature and things like that. So for the next video, you will need your calculator and your periodic table.